Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Subramaniam with a PhD in Chemistry. Today we are going to continue to make a quick revision of Unit 4 Chemical Kinetics Class 12. Already I have uploaded the first part of the lesson. Those who haven't watched can go back to the videos and watch it again. And we were talking about various concepts in our last session. And today I want to mention about the important things to avoid while preparing for NEET 2022 Chemistry. So far we talked about things that aspirants should keep in while preparing. However, with tons of distractions in our surroundings, it is also extremely important to talk about the things that one should avoid in how to study chemistry for NEET 2022. So here, avoid learning NEET chemistry from multiple sources. So, what you have to do is that a lot of study material will only make an aspirant confused. Therefore, just one coaching material and books mentioned. See, you will have got a list of, you might have got a list of different materials and books to study, but choose at least only 1 to 2 material or notes to follow. And don't set any limitations to the theory part. In order to make a steady hand in study for NEET Chemistry 22, you have to practice as many questions as you can. And don't slip into previous year's questions. Previous year's question papers will give a fair idea of what you can expect in NEET 2022 Chemistry question paper. So now we will get along with today's important topics that we have got to revise. And so what we are going to learn today is already you learned in our last session about what is meant by the rate of the reaction. We just understood about the rate constant. Then we were talking about the different orders of reaction, like zero order reaction, first order, and the overall reaction rate, and the equation relating the concentration of the reactants and the rate constant and all that. So today we will start with the reaction orders for a different type of reaction. You can see here. So here you can see that the concentration of X is 0.2, here it is double to 0.4, then again 0.8. Whereas in the case of Y, these two are same and this is double. And the rate will be, here you can see that 4, 8 and here 8 square 64. Now what is the order of X we can know from here? If the order of X is 1, then we cannot find out Y, order of Y in a straight way. For that you have to look at the whole reaction. So you can see that both reactant concentrations have doubled and the reaction rate has increased by 8 times. So what is the overall reaction rate? So 1 plus 2, 3, and the order of the reaction with respect to Y is X is 1 and Y is 2. The overall reaction will be, overall order will be X order plus Y order. So X order is 1 and Y order is also 1. Overall reaction order will be 2 and overall reaction rate is 3. So don't get confused between the reaction order, reaction rate and all that, overall rate and all that. Now next is zero order reaction. That is what is meant by zero order reaction. You get a, when you plot a graph with the rate as on the y axis and concentration on the x axis, you get a straight line, which is parallel to the x axis because the concentration does not change with the rate. So here the rate will be equal to the rate constant itself because reactant has no influence over the rate of the reaction. Next, what are the units of K? Units of the rate constant, it varies depending on the order of the reaction. So here I will be mentioning with a few examples how to calculate the rate constant. So for the first order reaction, rate is K into concentration of A. So rate is equal to, is expressed, this is the unit, whereas the A is expressed, concentration of A is expressed like this. So when you equate both, that is rate, this is equal to mole dm raised to minus 1, S raised to minus 1 is equal to K rate constant into A mole dm raised to minus 3. You cancel out these two, you get K is equal to S raised to minus 1. So for a first order reaction, K is equal to what you get, S raised to minus 1. Now for the second order reaction, you can see rate is equal to K concentration of A into concentration of B. So, rate is as always mole dm raised to minus 3, S raised to minus 1. For A and B, it is mole dm raised to minus 3. So, when you equate both, you cancel out these two, you get S raised to minus 1 is equal to K, or what do you get for K is equal to mole raised to minus 1, dm raised to 3 and S raised to minus 1. Okay. So, now next is another equation we will take. What are the units of K we were talking about? We took one or two examples, or we took the zero order reaction, first order reaction. Now, in this question, look at the rate given here, that is K, A, concentration of A, concentration of B to the power of 2. So, again we will try to calculate the rate in this case. Rate is mole dm raised to minus 3, S raised to minus 1, and A is mole dm raised to minus 3 and B mole dm raised to minus 3, it is 2 times. So, you put overall 2 times, and you have to always remember the units of K will vary according to the order of the reactions. Now, just equate both these. So, this comes 2 times. Okay. So, these 2 gets cancelled out and we get as K is equal to 2 times and dm raised to minus 6, S raised to minus 1. And for the next part, we will find out the relationship between temperature and K. That is, just remember, whenever the temperature increases, the rate also will increase. So, for every 10 degrees Celsius the increase, the rate will get doubled. So, again another equation, rate equation, rate is equal to KAB. Now, if you increase the temperature of A or B, then what will happen to the concentration? Nothing will happen, because temperature only affects K, it does not affect the concentration of A and B. Remember that point, it is very important. Okay, now K varies with temperature means it can be used to compare the same reaction at different temperatures. So, you can see a table here. What can you understand from the table? See, different temperatures are here. You can see the temperatures are getting increased, and also rate constant is also increasing. So, what can you understand from this? Temperature, when it increases, the value of K also will increase. So, it will happen only if the concentration of the reactant is same. If the concentration changes, this won't happen. Now, next, again, what is temperature? It is just a measure of the average kinetic energy. And always, in order for a reaction to occur or take place, the particles should be colliding with each other only, then they can react. And once they have to, they collide with each other, they will get enough energy to start breaking the bonds. So, that particular energy which they should attain or achieve, so that they get enough energy to break the bonds, is known as activation energy, which we call as EA. So, only if the particles have got an energy above EA, they will undergo reaction. So, here you can see that particles with energy 300 Kelvin and 310, you can see 2 points, and this is the activation energy. So, more particles will be above EA at higher temperature, and you can see. And now you can see another case where the temperature and rate constant are taken along the x and y axis. So, you know that Rn is equation. Here EA is the activation energy, then it's expressed in joule per mole. R is the gas constant value, you know already. T is the absolute temperature, and A is the frequency factor. So, you can remember the equation ln K is equal to minus EA by R 1 by T plus ln A. Just remember this equation, because you'll have to work out sums on the basis of this. So, accordingly, if you draw a graph with these points, you get a straight line like this. And next concept is collision theory. So, already I said that for any reaction to take place, the molecules always have to collide with each other, and when they collide with each other, what will happen, that they can react together or they may not react together. If they have to take part in the reaction, they should have sufficient energy, just enough to break the bonds. So, and also secondly, they have to firstly they have to collide. These are the conditions for any reaction to occur. Firstly, the molecules must collide with each other. Secondly, they should have sufficient energy. Thirdly, they must have the correct geometry. See, O3 plus NO gives O2 plus NO2. See the geometry given here. So, this is the correct geometry. and what is the difference? Instead of NO, it shouldn't be ON. So the attachment should be done in the proper way. Here it should be only ONO, it shouldn't be OON. So that is an important point which you have to remember. Then activation energy and activated complex. So energy barrier to the reaction and amount of energy needed to convert reactants into the activated complex. And what is activated complex? It's a chemical species with partially broken and partially formed bonds. So part of the bonds will be partially broken and part of it will be again formed, and always very high in energy because of the partial bonds. Remember these points. Then just take another case. A plus B reactants give you product C plus D. So we are taking two cases. The first one is exothermic reaction and endothermic reaction is the second case, and EA is the activation energy, which is the minimum amount of energy required to start or initiate a chemical reaction. Here potential energy, then reaction in progress. You can see A B reacts, then once it reaches activated complex, this is the activation energy, and it forms the product C plus D. Here this is the exothermic reaction, and you can see this point, the product is formed here. Another reaction I can show you for endothermic reaction. So they react and activated complex is formed. Here more amount of activation energy is needed and the product formed is shown C plus D. Now reaction mechanism, when you just go through those points, you can understand one important concept here. That is, the chemical reaction progresses, we can just split it into a series of simple steps. So sequence of steps which leads to the product formation is shown here. That is a reaction mechanism. See, for example, we have got an equation like 2NO reacts with O2 oxygen to give 2NO2. So you can see one thing is that N2O2, here nowhere you can see N2O2, but it is dictated during the reaction. How? So we will look into the elementary step. See, 2NO means NO plus NO. So NO plus NO will give you N2O2, 2 times N and 2 times O. So that is N2O2. So next elementary step is this N2O2. See, from here we get N2O2. Here in this equation we are not showing this N2O2. So that N2O2 reacts with this oxygen, C, and that finally gives you 2NO2. See, these two gets cancelled. So the overall reaction will be NO plus NO means 2NO plus O2 gives 2NO2. So that is the way which you have to understand the reaction mechanism. Now you have to know something about the intermediates. These appear in a reaction mechanism, but in the overall reaction you cannot see them. So intermediate will be always formed in earlier step and then later consumed in the later part of the step. See, as we already saw, these two got disappeared from the overall reaction. So the molecularity of a reaction means the number of molecules reacting in an elementary step. So for unimolecular reaction, elementary step with one molecule, bimolecular means 2 molecules, then trimolecular reaction means elementary step with 3 molecules. Okay, now with that we are coming to a conclusion of the second session as well. And most importantly, this lesson is having so many types of numericals you have to solve, and that too in the form of MCQs for NEET exam. Questions come from here. So include the most important question, or I have solved the sums for you in our MCQ sessions. And after this I will be uploading the next part of the unit. And always, as I say, do like, share and subscribe to my channel. Share it with your friends as well. And don't forget to press the bell icon so that as soon as I post new videos, you will get the notifications immediately. All of you would have known that NEET 2022 is likely to be held in July 2022. So I sincerely hope all of you are going through the portions really well, and the repeaters and re-repeaters are really working hard with your practice and to get a dream seat in the coming NEET examinations. And please do take your studies really seriously and don't waste your time. Revise all the portions, and whenever you get time, you revise all these concepts. Then until I come with the next unit. So that is all we have for today, and thanks for watching my video.